Now, there will be quite a few methods that you need to do, and a few techniques. First is a chain rule. You're going to think about the chain rule method of differentiation to determine the integrals with the product in the integrand. And look at the visible differential relationship, such as polynomials, radicals, negative indices, and exponential functions.
No,
all right. I will start doing trig next week. You need to recognize the difference between expansion and the chain rule method. So that is quite important. I'll give you two which looks pretty similar, but one of them is expansion, the other one is the chain rule method. And then use the method of differentiation and rearrangement to solve integral equations. This, I guarantee you, it will come out in the WAIS exam. I've seen a few questions on that in WAIS exam. Example 11 and 12. So we're going to go through it very carefully.
So what's the integral?
Now, if I integrate f dash x, which is equal to ax plus b to the power of n. Let's look at the situation when y equals to ax plus b to the power of n plus 1. All right? If I differentiate that using chain rule. So I need to differentiate the whole thing first. N plus 1, a plus b to the power of n. Correct? So I integrate that first before I integrate the inside. Remember, I said chain rule, integrate the outside first, then integrate the inside. Integrating the outside the bracket, so n plus 1, a x plus b to the power of n, and then times integrating that a. So therefore, observing that a times n plus 1, this is actually f dash x, ax plus b to the power of n. So if I want to integrate that, I have to divide it by a n plus 1, and there's n plus 1 there. All right? So basically, you need to think about how you're going back from f dash x. How do you go back to fx? All right? So how do you go back to fx? Think about how you can link this bit here to the original fx. Let's try with the very first one.
So
if you like, you can write that down.
You missed plus C, sir.
Plus C.
Plus C.
Plus C, I know, sorry. My fault. Plus C, I forgot plus C. I'll redo that, I forgot the plus C. All right, let's have a look at the first one, example 1. Now, look at d dx 3x plus 2. What is inside first? So you know what is inside is 3. All right? Now, what you can do is think about if I do 3x plus 2, d dx of 3x plus 2 is 3. Now, what if I do d dx of 3x plus 2 to the power of 7 to the power of 8? That would be 8 times 3x plus 2 to the power of 7 times 3. Correct? So you need to deduce how we go back to link that to 3x plus 2 to the power of 8. All right? So from there, you know that I need, if I have d dx 3x plus 2 to the power of 8, that should be 8 times 3x plus 2 to the power of 7 times 3, correct? So here, this is that. Agree? Now, I'm missing 3 and 8. So therefore, I need 24 times 3x plus 7. Integrating that is 1 over 24. So that I've got that back to the original form. All right? So think about how you can manipulate the integral. And therefore it's that. Think about what is inside first and then what is outside. So for 2, you should always write it in as a 2 minus 3x to the power of minus 5. See what I've done here? I recognize that there should be 3. So I need the 1/3 of that. All right? And then I also need that plus 1 divided by 8 if I want to integrate that. And therefore, I've got 1 over 24. Oh, not 1 over 24. 3x plus 2 to the power of 8 over 24. All right, try the next one, please. Think about dx, 2 minus 3x. What will you get? All right, that should be integrate 2 minus 3x to the power of minus 5 and dx. All right, this one at least I remember the plus c. The previous slide I did not. I'll have to change that. So that would be minus 3. So how would you do that? How would you do this? All right. So I do need a minus 3 out here and 1 over minus 3, correct? Right. Then I can integrate that plus 1 and divide it by 4. So therefore, you've got minus 1/3 times that, minus 3 times minus 4, you've got 1 over 12. 2x to the power of 2 minus 3x to the power of 4. Try 3, please. Write it in, instead of radical format, write it into the power of half. This one takes a lot of practice.
Fucking hell, man.
Good. For 3? Is this 3?
Yeah. I could have gone completely wrong. I just randomly did some shit.
So if I rewrite that, that would be it. And think about what is d dx of 5 minus
Negative
6x.
half so. Why is it negative half so?
Sorry? Oh, it's plus half. I have no idea why I put negative half. My fault is plus. I must be
What would you do?
looking at it. It should be plus.
No.
My fault.
Is it, I don't know if it's like...
It's not negative, it's plus, alright? That shouldn't be there. I don't know why I did
Do you
plus
times the
half.
integrals together? Is that what you're saying?
It's 3 over 2. I made a mistake. I stuffed it up.
Okay.
So,
Yeah, that's what you're supposed to do.
I have no idea why I did that. So I stuffed this one up completely. Alright? So if you look at this, 2 square root of 5 minus 6x dx is square root of 2, 5 minus 6x to the power of half dx. Alright? So I do know that I need a minus 1/3. So it should be minus 1/3
Why minus 1?
times minus 6,
Wait, what do you want?
5 minus 6x to the power of half dx.
Oh, because you got rid of
Alright, I stuffed it around completely, which means that would be minus 1/3, 5 minus 6x to the power of 3 over 2 divided by 3 over 2 plus c, which is minus 1/3 times 2 over 3, 5 minus 6x to the power of 3 over 2 plus c. Alright, I stuffed that up completely. I'll redo it.
Dumb mistake.
It's my fault.
Yeah, it's not.
I've
Well, I made a
done
dumb
it
mistake.
incorrectly. I did it as a minus half instead of half. That should be it.
Oh, I did
The
get that.
moral of the story is
I've
when you
seen
look
some
at
fun.
this sort of question, make sure that you're well awake.
Oh, so I'm going to make so many dumb mistakes.
Sorry?
I'm going to make so many dumb mistakes.
Oh yeah, I've preparing this lesson. It took me about 3 hours because every single example I made so many mistakes. It's not. It's funny, but it's not funny.
Surprised I got that right.
All right, next one. This one you got to do it twice. You got to think about this is there's an E as well.
You put a C at the end.
So how do you combine that? How do you combine that?
You don't H separately.
You can't actually combine that. You remember if I give you fx plus gx dx, you can actually integrate fx dx plus integrate gx dx. So you got to do it twice. You got to think about this and this. And I rewrite e to the 1 over e to the power of 2x minus 2x, e to the power of minus 2x minus 2. I'm trying to get as many varieties of examples as I can, but I can't show you every single step or every single one. I'm trying to get as many as I can. Alright, so think about first, how would you anti-differentiate that or integrate that? What is
I don't know how to do 5.
d dx of 3x plus 1?
Bro.
Alright? What is d dx of 3x plus 1?
that. Oh wait.
I don't know how to do. I don't know how to do it.
So you know that is
Do you know how to do the
3x
triangle
plus
one?
1? So that's a third using the chain rule. And then using the chain rule, you know that when you do this, it has to be minus 2.
I did it wrong.
Alright? Minus 2 times minus 2 is plus 1. Plus.
Yeah, I don't know how to do 5.
So think about the how you would go back to the original.
Did you just simplify
Alright?
that?
By
Did
looking
you
at
just expand that?
this
Yeah,
bit,
like
so
your
integrate that bit.
That's how I was thinking about
Sorry,
it. Oh, yeah,
differentiate that bit, or integrate that bit. Differentiate that and see how you go back to original.
Factor out x. Can't do that though, right? Yeah, you can't.
No, it's a split.
Alright, if I keep going, I've got that. And I can actually combine it if I want.
Yeah.
Yes. There's got to be a rule. There's no way you're expanding that out. Especially
So
when it's
combining
up to
it, like
power
for
4.
example, 1/3 times 3x plus 1 to the power of 5 divided by 5. I've got 15 as the denominator, and I rewrite that as 2e to the power of 2x minus 2. You can actually check it by going backwards.
If you go from the bottom,
Do this,
the next one.
differentiate this, and see whether you can get that. Check it. It's a good idea to check it. Yep. What was the question?
It's not meant to be a 3x plus 5 in brackets.
Sorry?
It's not meant to be 3x plus 5 in brackets, is it? Marked out.
3x plus 1, not 5. It's 3x plus 1, not 3x plus 5. I was looking at this 5 and I wrote down 5. No, it is 3x plus 1, it's my fault.
Mistakes. Alright, I got it. Okay.
I wonder if there's this whole
Told ya, I do make this sort of mistakes.
I feel like you get like mistake marks.
No.
They don't count. Because he makes more mistakes than us.
Alright. Are you all happy with this so far? This bit, you
Pascal triangle.
question like this, you need to split into two. Do it twice.
Sometimes I go off.
Now, let's have a look at this.
No,
Alright. Think about what's the difference between the first one, the left and the right. One is x squared, one is x is not. Alright? Now here, if you integrate this, what do you get? Just the inside, 2 plus x.
2x plus x squared.
No, what is just integrating 2 plus x?
2x plus
2x plus
Oh, you mean
Just integrate 2 plus x.
differentiate. You're saying integrate. Sir.
It's 1, correct? Let's not worry about it.
So the differentiation of that.
Differentiate, not integration. Differentiate that. What do you get?
One.
So this is not 1.
Yeah.
There's
So
an
this
x
is
there.
f of x.
What
F
if
dash
I
x times
integrate
f of
this?
x.
Sorry, differentiate this.
Which one?
This one.
2x.
2x. So here the 2x is there.
Yeah.
You can see that the 2x is already there. Right? So if I've got d dx 2x plus 2x 2 plus x squared, you know that the 2x is there. So that is actually related to that. This is related to that. Therefore, you can actually integrate this using a chain rule.
That's edge. That's edge.
All right, that plus 1 divided by n plus 1. You already know that, yeah? So you need to look at what is inside and differentiate that.
What do you do?
But if you differentiate that, you can't get 2x, you can only get 1.
Okay,
So therefore, this sort of situation, what do?
expand it out.
You expand it, you have to expand that.
No.
You expand 2 plus x.
That's actually
That means we
eight.
have to do that for fun.
See the difference? So I actually wrote this down, the note
How do you expand?
view. So note what is
E9, go back
inside.
E9.
Do the differentiation and differentiate what is inside and check that this
Yeah, but
is related to that. If
Yeah,
this is
so you
4x, you would know that there's an extra 2 out there. Alright? Whereas in this case, if I differentiate 2
Yeah,
plus
that's how I
x,
do it.
that's 1. So 2x does not equal to 1.
Bro,
Therefore,
I'm just doing
you
crap
actually,
on my head.
actually have to expand it. So expanding, you should be able to work out what the original, after integration, what fx is.
These are actually low-key easier than the other ones. It's just like a normal function.
The key to all this is recognize. Recognize, if you've got a bracket, a chain rule, what is, when differentiating that, can you relate this to that? Alright? Relate this to the integration of that. Alright? So it could be any, could be 5x, could be 6x, could be 7x, but then you know that
It's just
6x, you can change that to 3 times 2x. So that's 2x.
N plus C, N plus C.
If this is 6x, 3 times 2x.
Why is it over 2?
Got it?
Then why can't I do it for that one?
You can't because differentiating 2 plus x is 1.
Mate.
Why can't I multiply 1 by 2x?
Why is it 8?
You can't because
simplify.
you have to
be a
integrate
scalar multiple.
x as well.
as well.
In this case, it's not. This one is not related to whatever is out there. Alright?
Mine's here. This
So,
is my first
now,
one.
integrating products requiring expansion. So if fx is not related to
12
the
over 3.
derivative of gx,
3.
expand
12
the
over 4 is
integrand
3x.
and use the
Oh, yeah.
reverse power rule. Like that example.
You gotta be simplified.
Alright? Sometimes you need expansion if you cannot relate the fx to the derivative of gx.
Bro, I know where you make.
Let's try those two, please. So you can see that,
Wait, so we just gotta expand so for this.
yeah, you have to expand that. You really cannot, d dx of 1 minus 2x is minus 2. And you've got an x here, so you can't do anything.
No.
d dx of x is 1, and that's the square root of x. You really have to expand and then multiply, and use your power rule.
I love DXs.
Yeah. So do you have to simplify now?
Yes.
Do you have to simplify? Do you have to simplify?
Depends on the situation. Yeah, you probably do have to. And I forgot to take the attendance.
Yeah. I mean, bro, just do it anyway. It's not deep. It's like, it takes 1 second.
What's 12 over?
Bro. Wait, what's 12 divided by 4 joules? Wait, what's
8?
So, these two, you have to expand and use the distributive law. Alright? So you always must look at it to see whether this, anything, the outside fx here is
Yeah, it's
related
kinda
to
tricky.
gx.
Bro, crab claws, like, claws are the best method, eh?
Nah, don't even crab claw, bro. Just do a squared plus 2ab.
Yeah, how do you do that?
Yeah, mate, do that.
A squared plus 2ab plus c squared. That's it.
Yeah, do his way, you fail.
I mean b squared. Why? What? It doesn't apply to all situations, but
Wait, crab claws is actually the best method.
Alright.
Can't stop.
This one, expand, and this is what I get.
yep. And yep.
Alright, got 6 more examples to go. So you can see that example 7, example 8, and 9 and 10, whatever is outside is related to gx. The fx is related to gx. Got it? Let's go to the next example next week. Now this time we integrate products using the reverse chain rule or the chain rule type.
207.
So you know that fx is related to gx, right? So if you find
you got to integrate it. You just expand it.
if you derive gx to g dash x, fx is related to the derivative of gx. Then we can let y equals to gx to the power of n plus 1 and compare the derivative to the integrand.
Right. I'm actually going to fail this test.
So let's have a look at the first example.
I did 7, but
Example 7. Here, when I do dx of x cubed minus 2, that is actually 3x squared, correct? Yeah? So therefore you know that this is straight away. You can use it, you don't have to manipulate that, you don't have to do anything else. You can use it straight away. And that is just differentiating that is just x to the power of 3 minus 2. Why did I have an x here? There shouldn't be an x here. Minus 2 to the power of 4 divided by 4. Alright, there shouldn't be an x there. That's it.
36.
7 is pretty straightforward.
8, not so
If you
straightforward.
integrate 3x squared, doesn't that equal x cubed?
Sorry?
If you integrate the 3x squared, doesn't it equal x cubed?
Yeah, but you don't have to do that because that is related to what's inside here.
What did you do? Did you do 36 over 30 over 36?
Negative 36.
Yeah!
Negative 36.
I'm on it, I'm on it, I'm on it, bro.
Wait, nah, it's negative 36.
Yeah, I did it, bro. I did
Nah,
it.
you're shit, bro.
Bro, I'm one step ahead, fam.
Nah, shit out of here.
I do it all in one.
You didn't. You just didn't.
But I just did because I beat you. So
You beat me in the last test.
no, in that one equation right there. Shush, be
You
quiet.
got 15 over negative
Oh,
18.
shut up.
Wait, shut up. Hey, you didn't simplify. You want to talk about posse.
I got plus C. Oh, you didn't even get plus C, bro. My answer's more right.
So if you do this, 3x squared is here.
Wait, you can simplify 15 on 18.
Alright, the next one. If I integrate 3x squared, what is it? It's minus 6x,
Minus
correct?
6x.
So therefore, how do you change that? How do you
Because
manipulate that?
Because I'm thinking about adding the power, right?
How do
30
you
on
manipulate
36.
that?
Then times
So,
it there.
to make
times
sure
it by
that
the differentiation of this.
you've got what is
to
in
get
there.
36, negative 36.
So inside
Then
here,
wanna
if you
find a
differentiate
variable
that, you've got
times on
minus
the
6x.
outside to get
So to get from minus 6x to 30x is minus 5 times minus 6.
So y equals.
So you've got 30x there. Right? So make sure that you be able to manipulate what is outside to fit the differentiation of this one. So differentiating that, you get minus 6x. Differentiate the inside, 1 minus 3x squared, you get minus 6x, which is here.
Freezing. Kinda lost on this one, eh?
Differentiate what is inside first and relate it to this whole thing. Alright? So from there, this is what you do. Once you recognize all that, you should be able to do your integration.
Wait, no, I didn't simplify. I didn't simplify.
You didn't simplify?
I didn't simplify, yeah.
Alright, let's go on to example 9. Example 9, again, rewrite.
Example 9 is just the same thing.
It's the same principle. Once you get used to it, you can see that this is, if I do
Did you get for 9?
d dx of x cubed plus 1.
2.
It's not. It's
actually
It's
3x
just the
squared.
same thing, bro.
Right?
It's just.
So
Do the differential
rewriting
is, easy
the
though.
Oh, I did negative.
rewriting this is actually integrating
Half.
x squared x cubed plus 1 to the power of minus half. Alright? Rewriting that. So you are integrating this. And you know that this is related to that. I need 3x squared here. So, what I would then do is, I will have to put a 3 here and multiply it by 1/3. Because that will give me x squared. Correct? If I rewrite that, that's the same as that. So therefore, now you know that this whole thing, that will become 1/3
Oh yeah.
x cubed plus 1 to the power of that plus 1 is half divided by 1/2. Alright? Plus c, of course. Therefore, is 2/3 x cubed plus 1 to the power of half plus c. If you're not sure, always differentiate the end product and see if you can get that.
That's what I do.
Get your integral. So rewriting that, I can do that. 1/3 times 3 gives me 1, and that's it. You can either write in radical format or just write it to the power of half. I don't mind.
Teach me 10, sir.
Hmm?
Teach me 10.
10, alright. So if you look at 10, what do I do when I've got dx of 3x squared minus x cubed?
Expand.
No.
No!
I'm kidding.
That is 6x minus 3x squared.
Oh, to put
Correct?
3. Oh.
Yeah?
Easy.
So here, what do I need?
1
How
over
do
3.
you relate that to
1
this?
over 3.
So 3 times 2x minus x squared.
Yeah, buddy.
Correct? So it's 1/3 of that. Yeah?
Yeah.
Got it?
Yeah.
So once you've done that, you know that straight away that is going to be that. And if I've forgotten the plus c again. I've forgotten the plus c. I've forgotten the plus c. Alright, remember your plus c. Remember your plus c.
Like kind of like.
So you have to be able to recognize how this is related to that. See, if I integrate that, that will be 6x. This is 2x. Potential. Integrate that will be 3x squared. 3x squared. Alright? So how do I relate 6x squared minus 3x squared to that? I need to multiply that by 3. If I can multiply that by 3, I can manipulate that, multiply by 1/3 as well. So 3 divided by 3 is 1. I'm just changing the appearance of this, not the value.
Is 11 supposed to be hard?
Yes. Right.
The next bit will be the hardest bit, alright? Because you've got to think about using your ddx as well as your integration technique. Are you ready for me to move on to the next one? 1 more minute, okay. The next one is actually the hardest.
Yeah, right. I just didn't think.
Oh, so I figured it out.
I figured it out. So you just go both sides. This cancels out. You get 2x e 2x minus this. Get 2x e 2x c minus.
Wait, why are you doing the derivative?
What?
Oh, that's what we're trying to find out. Yeah.
No. Because.
All right. Let's go to the next state, last
You
bit.
think it's e to the 2x.
Now,
Differentiate e to the 2x.
this time, you
get
really
2e2x.
you
Something
really
like
need
that,
to
right?
think about how you could use dy dx of fx gx to determine hx gx. All right?
Oh, but a
Very interesting
2e2x
concept.
plus 4x e to 2x. Remember, product.
And you need to really concentrate on this. All
Product
right?
rule, yeah.
So I've got fx and gx of a product.
See,
The
you rearrange it,
derivative of that can actually help you
integrate
find
both
the
sides, and it
derivative of
cancels out
this.
differentiation here. So you just
Alright.
get that, and then you minus.
So generally the question, something like this will come out.
Sorry, this is supposed to be
as
here as well.
Determine this. And then from there, how do you determine that? All right? You can see that this and this is related. Sort of related. You've got 2x here, but you've got 4x here. All right? So let's start. This is actually a waste exam question. So the first bit, you should be able to use your product rule. All right? Now, using your product rule, d dx 2x to the power of e to the 2x is 2e2x plus 4x e to the power of 2x, correct?
Yep.
Now, the thing is, if you look at this, if you differentiate 2x, it's actually only 2, but there's an x here, and you cannot expand e to the power of 2x at all. There's no way that you could expand e to the power of 2x. It's not a binomial product. It's not something. It's e. All right? So therefore, you think about how you're going to relate 2x, e to the power of 2x, find the differentiation of this, and then how do I work backwards to find the integration? See, once I differentiate that, I've got this bit here. E 4x to the power 4x times e to the power of 2x, correct? Yeah? That is related to that. Agree?
Yeah.
Yeah? This is actually exactly the same term as that. Yeah? So how on earth am I going to use this information there?
Rearrange.
To actually, yes, rearrange. So how do I rearrange? Alright, how do I rearrange? You now know that, listen, you do know if you look at this.
Oh, so the integral of that is equal to the integral of that.
This is d
Oh,
dx
well, the integral of
of
the negative of that.
2x e to the power of 2x equals to 2x
That's right.
plus 4x e to the power of 2x, correct?
Oh.
Now, rearranging it, you can actually rewrite this as 4x e to the power of 2x equals to d dx 2x e to the power of 2x minus 2e to the power of 2x. All right? So you can actually rewrite it that way. All right? Rearranging that. Rearranging that. What we want is, we want this to be the subject. We want this to be the subject. Yeah?
Yeah.
Got it? So I want that to be subject, and then I can integrate this, because integrating this is the same as integrating that bit, the left-hand side. Yeah?
What?
Got it?
Oh,
Do
right.
both
Yeah?
sides.
You're going to rearrange that. Because integrating this, what will I get?
2
Just
x.
that.
Just that, which is 2x e to the power of 2x, and then you can integrate that separately, right? Because that's related to, if you derive 2x, you've got 2. Yeah? So this is a tricky one. So therefore, rewriting that, you know that this is equal to d dx of that, take away that. And therefore, integrating this is the same as integrating that. Now, integrating this is basically that bit, correct? Yeah? 2x e to the power of x. Agree? So therefore, then you can integrate that, which is e to the power of 2x and plus c. Alright?
Wow.
So this is, like I say, this is an exam question. I think this is a waste 2016 question.
2016.
6, I think. 6 marks, I think. So you've got 2 marks for A. 2 marks for A, and then rearranging and differentiate that, and come up with the last answer. I think that's 6 marks. I cannot remember the mark allocation. This is, I'm pretty sure it's 2016 waste exam question. All right? Now, I want you to try example 12. Example 12 is taking it to one level higher because it is slightly different. You know that you need to do ddx something, and how you rearrange that is what you need to do. All right? So let's start off by finding the ddx of 2x e to the power of 3x minus 1. Example 12 is slightly more difficult. It involves a different manipulation altogether. So part A, I'll give you a couple of minutes to do that. Use your chain product rule, not chain rule, product rule. All right, if you've done your product rule correctly, it should be this. Do you agree?
So you do the first
now,
2x
what happened here?
times this part
Can I relate this to this?
Yes.
plus this part
By?
times
1 over 6.
1 over 6. Now, do I want to do 1 over 6 first? Not quite. See what I've done. So I'm doing this first. I'm rearranging that. Alright? I'm not going to divide this by 6, divide this by 6, divide this by 6 first. No point. I'm going to leave it as that bit first. Alright? Although I know this term is not the same. It's just 6 times of that. But you do know that if I integrate a times fx dx, it's actually a integrate fx dx. So I will leave the 6 out first as a. Alright? So I will do it that way first. I'm going to stop here. I'll let you continue on.
What'd you get?
1 over 3 e 3x minus 1 minus 1 Yeah, you got it.
Now,
Oh wait, I'm missing x.
so therefore, you now know integrating this
No, but it's right.
Yeah, see x there.
is integrating this, take away integrating that, correct? So here, straight away you know that that's 2x e to the power of 3x minus 1. I can tell you this example took me about 20 minutes to work it out. But once you know the trick, you should be able to keep doing that. So therefore, I know that differentiating that is 2x e to the power of 3x minus 1. and you should be able to differentiate that. All right? 2/3 e to the power 3x minus 1. Because differentiating this is 3. So you need to multiply 1/3 in.
Why is it?
Now, here, then, once I've got that, I can divide everything by 6. Yeah? So make life a little bit easier for yourself by keeping the 6 there without dividing the 6 first. Divide the 6 at the end. Alright? So you don't, what I would do is I will not divide the 6 straight away. So if not, you'll be thinking about fractions. I'd rather not work with fraction first. I will work with the whole number first and then find out.
So would this C be on 6?
Sorry?
This one, yeah.
Yeah?
Would the plus C be on over 6?
Oh, it doesn't matter. Just a constant.
Oh,
it can
right.
be
It'll
over
be the
6.
same
It's just a constant
And also
because the
the-
number is just make sure it's constant. That should be
9.
9.
Yeah.
Yep, that should be 9.
Do you understand everything I'm doing right now?
That should be 9. My fault. That should be 9.
From there, you should be able to figure it out because
Alright.
we just did all of that. Just
Yes, it is my fault.
Well, we did this part yesterday.
So this is, you can see that this is taking it just a little bit higher. This is probably one of the most difficult examples that you can get. Like I say, it took me about 20 minutes to figure it out.
You got to put something at the front.
It wasn't an easy
Make
example.
that.
All right, so I think I've given you enough examples. You should have questions that you can do from Sadler.